Okay, cool. All right. Well, hello everybody, and welcome to our second NextGen Lab meeting. This is going to be a monthly event. This is the third Wednesday of every month, and it's going to be live and then online and posted on our website at nextgensd.com. Go under the News and Events tab, and you'll see the NGen Lab meeting. So we'll archive the past presentations and give you information about the ones upcoming. So just kind of a brief introduction to things going on within NextGen right now is there's a lot going on. The summit is coming up at the end of October, the 27th, 28th, and 29th. So the slots for no fee for registration have been filled, but we are accepting some paid registration slots. So please, if you're interested, email us at nextgensd2012@gmail.com. And of course, there's more information on our website on the summit page, which you can navigate to easily. And very importantly, is that we are currently accepting proposals for sessions. So at the summit, we're going to be not giving actual formal presentations, but discussing issues of mutual relevance. And so to do so, we are going to have people that are going to be proposing different sessions that we can address and prepare for before the event. And so to do that, follow the instructions on our website. In addition, right now, the special issue, the NGen special issue of the Journal of the Southwest is in its final stages of development. We're finished the copy editing stage and are finishing the cover and going forward. So that will be, if all things work out, like it looks like it's going to, in our hands by the summit. In addition, if you haven't seen it, look for the La Jornada Suplemento Ecológico, which is an environmental themed supplement of the UNAM La Jornada newspaper. And this summer's version is focused on mining and the new effects of mining throughout Mexico. This actually came from an opinion piece, a kind of position statement that Nemanarchi, Alberto Borges, and myself wrote with the broad support of the NextGen community on the development at any cost, the new face of mining in Mexico and across borders. And this spurred some media attention, including from La Jornada, and they wanted to develop a whole supplement and on this very topic, and that's what happened. So we revised our intro chapter, which kicks off the supplement, and many very important contributions. So please keep an eye out for that. It is on our website, and you can go to La Jornada's main page. And stemming from that is going to be some actual focused work and in the field and getting our hands really dirty and focused on this topic of mining. And we are currently in the midst of preparing and planning for an expedition to the Sierra La Laguna in response to the Los Cardones open pit mining project. This is really right in the development as I'm speaking, and keep your eyes posted for some new announcements and calls for people that can be able to help us in bringing some biodiversity information to that region. So those are just kind of hitting the top of the iceberg of what's going on with NextGen. And now let's get into today's presentation. So Christopher, thank you very much for joining us. And I'll briefly kind of let people know a little bit about your work. So Christopher's work focuses on the policy dimensions of global change. So he's currently the leader of the Water Resources Policy Group, among other various organizations that he's helping direct. And the Water Resources Policy Group specifically, which is very relevant to his presentation today, communicates between disciplines and cultures in the arena of the challenges societies face with water. He has over a decade of experience living and working in India, Nepal, Sri Lanka, and especially Mexico, as well as 2 years in Honduras and India working with non-governmental organizations. So he's published extensively on the topic he will present on today and is truly fantastic at organizing and catalyzing collaboration. Christopher arrived in Tucson at the University of Arizona in July 2006 and really brings a global perspective to addressing what is and will increasingly be one of the most significant issues in our region in the modern age, and that's water, especially across borders. So it is my pleasure to now be working with Chris on the Consortium for Arizona and Mexico Arid Environments, and for having him with us today to present in our second Next Gen Lab meeting. And I look forward to really hearing and learning a lot more about this issue. So Christopher, take it away.
Thanks very much, Ben. And maybe just a word out on that last appointment of Ben as a research scientist. When we set up this August 19th NGen presentation, Lucero and Ben asked me maybe in June or something, the whole idea of asking Ben to apply for the position we had not even surfaced. So please don't take this as Ben's new boss insisting that he's got to have a captive audience to speak. I have heard about NGen. Ben was right here in this room. I happen to be sitting at the Udall Center for Studies in Public Policy maybe 4 years ago, 4 or 5 years ago. Talked about NGen. A number of my students are members, postdocs and others. So this is just a great opportunity for me. And added to that is the chance to work with Ben and through Ben with NGen and a whole series of other engagements on the border. Okay, so let's get going on what will be about a half an hour or so, 35-minute presentation. And I won't go formally through the slides, but let me do one thing. Lucero me indicó que la membresía de NGen habla tanto español como inglés, y como las dos ponencias que tengo, la primera es en inglés, digamos la redacción de la ponencia. Ustedes que hablen inglés pueden leer las diapositivas y yo voy a exponer en español. Y en la segunda parte, las diapositivas son en español y voy a exponer en inglés, si les conviene. ¿Sí? Ok. Voy a presentar rápidamente los avances de un proyecto que tenemos financiado por el National Science Foundation, programa en Coupled Natural Human Systems, sistemas naturales y humanos acoplados. Un proyecto que está en marcha y estamos casi entrando al último año. A ver, ¿cómo avanzo? Sí, perdón. Aquí. Es un equipo netamente interdisciplinario e internacional también. Varios de nosotros acá de la Universidad de Arizona en ecología, recursos hídricos, ingeniería también. Las ciencias sociales, sociología, geografía, etcétera, y colaborando en este caso con la Universidad de Sonora, el Colegio de Sonora y la Universidad de Copenhagen en Dinamarca, que aquí abajo a mano izquierda en la parte inferior pueden ver el colaborador danés que nos trabaja en Agent-Based Models. Bueno, el diseño del programa es investigar las dinámicas ecohidrológicas, y eso es a través de cobertura de suelo, land use, land cover, y no solamente el mapeo mediante sistemas de información geográfica y sensores y percepción remota, sino que el modelación también de la dinámica. Estamos investigando en campo los procesos fisiológicos, ecosistémicos, y entrando a lo que es el análisis de los servicios ecosistémicos. Con esto queremos caracterizar las fuentes y la variabilidad de la recarga hídrica, es decir, la precipitación que recibimos, cómo los particionamos, la dividimos entre flujo superficial y recarga a los acuíferos. Como ustedes saben, en nuestra zona los acuíferos subterráneos es una fuente muy importante, no solamente de agua para uso humano, sino que también la recarga de lo que llamamos el flujo base, el base flow en los ríos de nuestra zona. Gran parte viene de descarga de los acuíferos en un proceso que se llama la interacción superficial subterránea en ríos efímeros, como el río San Pedro, el río Santa Cruz, acá en nuestra zona, y varios ríos en nuestra zona de estudio y de interés de ustedes. Queremos cuantificar el bombeo, que es la extracción de agua de las cuencas y los acuíferos, y también en ciertos casos si hay flujo superficial, gasto, digamos, escurrimiento superficial en presas o en también muros de contención, gabions, etcétera. En ciertos casos pueden haber extracción de las aguas superficiales. Con esto queremos realmente estimar el estado y también la dinámica temporal de la hidrología y vincularlo con las condiciones ecológicas. Mucho de lo que hemos mencionado acá tiene mucho que ver con el uso humano, la dinámica social, institucional, cómo los usuarios de agua están organizados, también regulación por parte del Estado, inversión, etcétera. Entonces, consideramos que no se puede separar la ecohidrología de la dinámica social institucional. Por eso, estamos investigando históricamente los documentos, haciendo un análisis institucional y a través de entrevistas y focus groups en forma semi-estructurada, recopilar información social. Organizar también talleres, workshops de intercambio, y voy a hablar rápidamente después sobre un proceso que llamamos el diálogo ciencia política, no solamente presentar nuestros resultados científicos, sino que a través de estos workshops también solicitar las opiniones y también hasta preguntas de investigación, research questions, que diseñamos a través del intercambio con tomadores de decisiones. Bueno, rápidamente estamos trabajando en dos cuencas. Una es la cuenca binacional México-Estados Unidos del río San Pedro, que nace acá. Espero que puedan ver mi cursor acá cuando indico que la ciudad de Cananea, Sonora, es uno de las fuentes principales del río San Pedro que transcurre a través de la frontera binacional México-Estados Unidos y llega aquí aguas abajo en sentido norte a Sierra Vista y, bueno, Fort Huachuca y Bisbee y todo eso. Por otro lado, una cuenca más grande es el de Río Sonora, que nace también, acá es Cananea, la misma Cananea, y hacia el sur nace el río Sonora, pero básicamente estamos trabajando sobre nada más una de las subcuencas, que es el río San Miguel. Para ustedes que han viajado de Hermosillo, capital de Sonora, hacia Tucson, en sentido norte-sur, la carretera internacional número 15, esa es la cuenca del río San Juan. Pero acá hacia el este es el río Sonora. Bueno, en esta gráfica lo que ustedes pueden ver en colores azules es cuando la precipitación pluvial o nival ocurre mayormente durante la estación de invierno. Es un tipo de precipitación mediterráneo en cuando la precipitación ocurre durante el invierno, mientras que en el extremo este de nuestra zona de frontera, en el estado de Chihuahua y hacia el norte de Texas y parte de Nuevo México, la precipitación es ahora durante el verano. Eso tiene mucho que ver entonces con el tipo de vegetación, con el tipo también de los procesos y la dinámica hidrológica, y nuestra zona de estudio es justamente en medio de estos dos. Digamos, es una gradiente, y entonces tenemos que entender no solamente los cambios en el régimen climático, sino que la estacionalidad de la precipitación, porque influye mucho, tanto en la parte ecológica como en la parte también humana. Entonces estamos en el Sonoran Desert, ustedes saben mucho mejor que yo qué implica esto, un sistema dominado por el monzón, pero también precipitación bimodal en el que recibimos también durante el invierno. ¿Alguien está conectando por... ustedes me pueden indicar si me escuchan? Espero que si yo sigo hablando, alguien sí me escucha ahí, aunque me suena el tono de Skype. Existe también el San Pedro Riparian National Conservation Area en Arizona, y en Sonora existe el Ajos Bavispe, la reserva Ajos Bavispe. Bueno, para dar un poco la fotografía y panorama de la zona, ustedes muchos conocen a estas zonas, y lo que tenemos en México, acá en la ciudad de Cananea, con la mina. Ben justamente ahorita mencionó el caso de minería. Esta mina de Cananea es una de las más grandes del hemisferio. Inclusive en Chile y Perú hay otras minas también de cobre muy importantes que son de esta escala, y voy a hablar en la segunda parte de la presentación sobre la actividad minera y sus impactos en la hidrología. Bueno, agricultura de pequeña escala, también grasslands de este tipo, pastizales, etcétera, uso de suelo de este tipo, de pequeñas, digamos, represas de contención de aguas pluviales, rainwater harvesting, aprovechamiento de aguas, digamos, pluviales. Y hacia el sur, hacia el norte de la frontera, en sentido aguas abajo, en el río Sonora, ciudades un poco más importantes, Sierra Vista, Douglas, Bisbee, Benson, etcétera, y con digamos, un impacto urbano en las cuencas muy importantes. Pero en donde este es el famoso flujo base, que es la conexión del acuífero con el río, y la importancia de la vegetación riparia, willows y cottonwoods, álamos y sauces y todo eso. Y un poco hacia el sur se nota también que la precipitación, principalmente por el efecto del monzón, en el río Sonora y el río Bavispe, que es afluente del río Yaqui, en el estado de Sonora, que nace en Chihuahua y escurre hacia el estado de Sonora. Y pueden ver también los pueblos típicos que se concentran sobre el lecho del río en la zona riparia. Aunque no se nota realmente, pero es el efecto de la eutroficación, digamos, las descargas de residuales, aguas residuales, y también los nutrientes que hay que considerar también en cuestiones de calidad de agua cuando se habla de ríos impactados. Voy a mencionar rápidamente un poco ¿cómo se llama? El derrame que sucedió hace un año aproximadamente, y ahora que todos estamos viendo los impactos en el río Ánimas en Colorado y Nuevo México, que sucedió algo similar acá con el desbordamiento de muros de contención de aguas de la mina Grupo México Cananea, que escurrió hacia el sur y contaminó gran parte del río, y hasta hoy la gente no se puede tomar agua del río, y también los pozos aledaños se ven afectados. No voy a entrar mucho en detalle en lo que nosotros estamos investigando, pero un poco para colocar esta problemática sobre los desafíos de manejo de los ríos y los corredores riparios. Ahora, viendo un poco la cuenca del río Sonora, y en particular el río San Miguel, investigamos el derrame de estos muros de contención acá abajo, y si esto hubiera ocurrido con escurrimiento binacional desde Sonora hacia el norte alcanzando Arizona, les puedo asegurar que digamos, la atención en los medios digamos, de la prensa, etcétera, hubieran sido mucho mayores, que en este caso, semanas después, básicamente pasó de ser de interés fuera de lo que son gente de la zona, porque es su fuente de agua y su vida, no solamente económica, sino que cultural, etcétera, etcétera también. Estamos trabajando entonces en el río San Miguel, en 4 de los municipios, investigando el uso y aprovechamiento de las aguas en acequias, en la actividad ganadera, en industria de pequeña escala, y tratando de entender el vínculo entre los procesos hidroecológicos y la parte económica y la parte social en la cuenca. Aguas Abajo o Poderpe es uno de los municipios menores, digamos, en cuestión de población, mucha inmigración que sale por escasez de agua y no tener muchos, digamos, medios de sustento de vida, porque el régimen hidrológico del río no da sustento a agricultura y ganadería como es en los otros municipios, por ejemplo, el caso de San Miguel Orcasitas. Ahora, aquí aguas abajo en San Miguel, el acuífero abre y tenemos depósitos aluviales muy profundos en donde el agua almacenada es de mucha antigüedad. Mediante estudios isotópicos hemos comprobado que las aguas que hoy en día se está aprovechando para abastecer agua a la población, actividades de este tipo, data de varios siglos y hasta milenios atrás. Así que estamos experimentando un proceso que se llama el groundwater mining. Es un fósil, un agua fósil, que básicamente cuando la acabamos no se vuelve a recargar en digamos, nuestros horizontes de tiempo. Bueno, entrar a detalle a balances hídricos, las entradas, las salidas, que cuánta agua hay, entonces dividiendo la cuenca o la subcuenca del río San Miguel en 4 diferentes tramos, river reaches. Acá podemos apreciar que el escurrimiento, que es de agua superficial, cada vez se viene bajando desde la parte alta a la parte media, a la parte media baja, a la parte baja, que aquí aguas abajo, siguiendo en Hermosillo, el río no escurre, aun si produce precipitaciones importantes, pero también lo que podemos apreciar es la infiltración y también notamos la diferencia en la precipitación. Este es un efecto orográfico en las montañas, llueve mucho más que aguas abajo, que se ven las tendencias a la baja de la precipitación, y esto afecta también los balances hídricos. Colegas en la Universidad de Sonora está haciendo un mapeo del flujo de las aguas subterráneas, entendiendo por dónde se dispone de esta agua, cómo llega, cuáles son los procesos de recarga desde la superficie, pero una vez que está en el acuífero, cómo es el flujo y el movimiento de las aguas. Ahora, ligar todo eso a los servicios ecosistémicos, en donde tenemos los procesos biofísicos, ecosistémicos y la parte de instituciones del uso humano, el gobierno, la regulación, las leyes, etcétera, y en donde el servicio es el aprovechamiento que el ser humano o la actividad social económica hace del agua, por ejemplo, de tener agua limpia, protección o atenuación de las crecidas, las inundaciones, y luego convertir esto en beneficio, en servicio, y tratar de aplicar también un valor económico. Quiero enfatizar que el valor económico no es el objetivo central. No estamos estudiando todo el resto del ciclo solamente para asignarle un valor, pero las actividades locales a veces cambian dependiendo el valor que los usuarios de agua tienen. Puede ser que hoy en día la actividad agrícola te rinde más que ganadería, o que van y venden su mano de obra en la minería, así que hay que entender bien el balance entre el ciclo económico y el ciclo más hidroecológico. Este trabajo de mi colega Mitch Pavao-Zuckerman y su estudiante de ahora doctorado en el EEB Department aquí de la Universidad de Arizona, Ecology and Evolutionary Biology, Moira Huff, que hicieron una clasificación y una taxonomía de diferentes especies, que cada una está adaptada a cierta, digamos, cierto régimen hidrológico de la profundidad del Napa, digamos, el nivel freático, y especies, por ejemplo, ¿cómo se llama? El Gooding's Willow y el Cottonwood álamo no pueden aguantar cuando las aguas superficiales bajen por debajo de 2 metros o 3 metros el nivel freático, se secan y mueren, mientras que Prosopis, por ejemplo, se ha comprobado que hasta 50 metros y más de profundidad. Y estamos colaborando con ciertos colegas acá en geografía y otros departamentos en la Universidad de Arizona para estudiar la redistribución en la matriz del suelo mediante la digamos, acción de las raíces de especies como mezquite. Luego convertir todo eso y armarlo en un modelo que llamamos el Agent-Based Model. Probablemente varios de ustedes han trabajado con ABMs o han leído y escuchado presentaciones sobre la interacción. Y en este caso lo concebimos como una interacción entre la parte social, la parte hidrológica y la parte ecológica. Este es ahora trabajo de una estudiante de doctorado en the School of Natural Resources and Environment, Aloha Pope, y Aloha está terminando su doctorado bajo la supervisión, la colaboración con el profesor Randy Gimblett. Entonces, considerando otra vez la parte social, las dimensiones humanas, la hidrología y la ecología, sin entrar realmente a mucho detalle, pero es algo que hemos logrado hacer a través de las diferentes fuentes de información que anteriormente he descrito, la parte ecológica, la parte hidrológica. Y entonces el uso de suelo, también el land ownership, si es digamos tierra en manos privadas o en la parte más pública, lo que pueden ver en México es gran parte es del sector ejidal y también digamos uso privado, mientras que en Arizona es un poco más un checkerboard, como decimos, ¿no? De tierra, digamos, en manos públicas, también en privadas, state land, etcétera. Y esto influye un poco en las posibilidades de gestión y manejo. Ahora, este es análisis de dos de los estudiantes, Lily House Peters y David Chan. David se ha ido ahora a Kentucky y Lily está terminando su doctorado estudiando la evolución de la vegetación a través de los primeros satélites MSS, Multispectral Scanner, que se lanzaron en los 70. Entonces tenemos ya casi 40 años y más de, digamos, evolución de la vegetación. Y ahora, un poco para entender cómo concebimos los impactos para considerar escenarios a futuro. Entonces, esta, digamos, matriz indica la potencial de impacto. Si algo sucediera con SES, es el social-ecological systems, ¿no? Entonces, si la interacción social ecológica produce impactos, digamos, no muy importantes o muy importantes, y su probabilidad que se ocurre. Por ejemplo, high value low water crops would replace grains, en este caso en México, y esto llega a suceder, no tiene gran impacto, pero la probabilidad también de que realmente se reemplaza totalmente los granos básicos por cultivos de alto valor, no consideramos que es de muy alta probabilidad, porque gran parte de la agricultura es de pequeña escala y la high value, etcétera, requiere de mercadeo, requiere de muchos insumos, etcétera. Pero en cambio, otro escenario que puede ocurrir, digamos, con alta probabilidad, porque ya es algo que se produce, digamos, que se puede observar en el campo, es la invasión digamos, de gramíneas, etcétera, no nativas, tipo buffel o layman's love-grass, que cada vez están, digamos, invadiendo a nuestros grasslands. Y esto se aplica en la interacción social ecológica, es algo que ya se está adaptando a ese tipo de cambios. Entonces tampoco consideramos que es de muy alto impacto, mientras que otros escenarios también son de baja probabilidad o alta probabilidad, y su impacto, si se llega a producir, es en este caso alto. Si Fort Huachuca se llegara a cerrar, existe un Base Closure Commission. Eso tendría gran impacto no solamente en el uso de suelo, sino que en la economía local regional. y en este caso, si drought frequency se llega a producir o las sequías se presentaran más frecuentemente con el cambio climático, eso, claro, sí tendría alta probabilidad y tendría también alto impacto porque cambia totalmente los balances hídricos, la cobertura de suelo, el uso de suelo, etcétera. Entonces, es un poco la forma en que alta y baja probabilidad y alto y bajo, bueno, bajo y alto impacto. Entonces, armamos una serie de escenarios y con stakeholders, usuarios de agua, representantes de gobiernos locales, interesados, investigadores, no nosotros del equipo de investigación, pero digamos profesores de escuela, etcétera. Entonces, es un mecanismo, scenario planning, a través del cual se dice, consideren por favor si ese tipo de cambio se llegara a producir en su cuenca, en su comunidad, en su región, ¿cómo lo marcarían? ¿Cómo lo calificarían? ¿Cómo sería en el rango de probabilidad, baja o alta? ¿Cómo sería en el rango, digamos, de impacto, bajo o alto? Pero no recuerdo bien el escenario número 2 y el número 5, pero estamos interesados en estos escenarios que son de alta probabilidad y alto impacto. Si algo se mapearía aquí, bueno, bajo impacto, baja probabilidad, probablemente no tenemos que preocuparnos mucho por esto. Bueno, eso es un panorama un poco de lo que estamos haciendo a través de este proyecto en la región transfronteriza Estados Unidos-México, básicamente Arizona-Sonora, en la región del desierto de Sonora. Ahora, si me permiten, voy a ahora cambiar a la segunda parte de esta ponencia y lo que habíamos indicado en el título de mi presentación acá en WebEx es un poco, no la expansión del mismo proyecto, pero los estudios que estamos haciendo en cuestiones de seguridad hídrica, y voy a explicarlo un poco, pero no nada más acá en la zona ahora de Arizona y Sonora, la frontera Estados Unidos-México, sino que también en el hemisferio sur. Entonces, si me permiten, now I'm going to change over to English to speak because those who are following in Spanish can read the slides. So this is an initiative that goes back a number of years to 2011. There's even background before that, but where this group that you will see the logo of right here called the Inter-American Institute for Global Change Research, and very briefly IAI, and here is the director, and here is the program officer of IAI, and various of us in this photograph have been project holders, but we also had stakeholders here from Protección Civil and Conagua and the Central Arizona Project, et cetera, et cetera. But we got together to hold a workshop on science policy, to bring policymakers and scientists together to really talk about climatic risk and water security, and water security being that, and we have now new work to get into the concept of water security, is to have adequate supplies of adequate quality of water with access and the distribution for humans and ecosystems over the long term. So it's a resilience and sustainability concept that itself is the goal, and then there's various adaptation processes and resilience and social-ecological systems processes that allow for regions and river basins and communities to be water secure or insecure in some fashion or the other. We were asked to set up something called the AquaSec Center of Excellence for Water Security. It's not a physical center. I'm not sitting in AquaSec's offices or buildings. It's a virtual center. It's basically a network of people from at least 6 different countries of North and South America, all working on different questions related to water and water security planning, long-term sustainability, with that notion of human and ecosystem uses linked to hydrology, climate, and climate change drivers. So we're one hub of it, hub of it, and the other is the Pontificia Universidad Católica de Chile, and somewhere in here is my colleague, Francisco Mesa, who is a professor here of the Católica in Chile. He brought his water resource manager from the Chilean government and several other partners. This is the city of Santiago's water supply manager, somebody from the water company that was interested in climate change processes, and so this is this sort of science policy process that we're involved in. Very rapidly, many of you have seen these kind of broad-scale global projections. We all know that climate change is bringing us, or we are coming into a warmer world. Temperature trends are on the rise. That is, I'll say, undeniable. That is just a factor and a feature of climate change. Uncertainties exist with just how much we will get over the course of the century with these kinds of projections. Some have it up in terms of 4, 5, 6, 7 degrees. You can see even the polar regions are going to have temperature rise over the coming century of 10+ degrees centigrade. Now, the precipitation, the rainfall snow regime is more complicated. This, of course, climate processes drive the water cycle. More heat, greater moisture capture in the atmosphere actually drives a more rapid hydrologic cycle. But that also tends to be with greater precipitation concentrated on the poles and to some extent the equatorial region with, and this is a feature of Hadley cells, the semi-arid and arid regions in the northern and southern hemisphere, extratropical regions are likely to, with some degrees of certainty and uncertainty associated with decline in precipitation. So if we are in, and much of Mexico and the border region with the United States, but just as you will also see in parts of coastal South America, parts of Peru, Chile, Argentina, just on the other side of the Andes, even parts of northeast Brazil, which we also have some collaboration, are both getting warmer but also getting drier, and this really changes the hydrological processes and the availability of water. So this is a talk I gave in Mendoza, Argentina, based on some work that Chilean colleagues, again, Francisco Mesa and his team had done. So you'll see the Chilean regions outlined here. But what is also interesting is on the eastern side of the Andes, and you start getting this very important wedge kind of coming down. Well, the impacts of temperature rise in the Amazon up here is very important. I don't want to say it's off our map. We're looking at that, but since we're an arid region kind of focus, but the future century does augur a 4+ case of temperature rise, of course, near the polar regions. In this modeling set of scenarios, perhaps a little bit less. Precipitation, again, not quite so easy to model. Lots of downscaling questions, lots of physical process, GCM, global circulation model kinds of questions. But what you will see is regions, for instance, here of northern Chile and Argentina, drier and getting potentially drier with changes in rainfall regime. Now, keep in mind what I'd said earlier in the border, U.S.-Mexico border part, is it's not just the total amount of annual precipitation. It is that split between summer and winter. So we're also interested, because each of those produces obviously a different runoff regime in the rivers, but it also is very important for the way groundwater is recharged. And so we're looking to expand some of that. So now this is back out to some of those sort of more integrated social and human questions where we're focusing, and as I presented here, sort of the North American, southwest U.S., northwest Mexico arid region, the Pacific coastal belt going all the way up here to, and I was just in Piura, Peru, almost on the equator, just south of Ecuador, all the way down the whole coastal Peruvian part, coming down into Chile, the Chaco region, and then this whole part of northeast Brazil, which is the Rio San Francisco, the Rio San Francisco in Spanish, which is basically Brazil's workhorse river. Some people have likened the Colorado River here, and the Rio San Francisco being these very important sort of their water sources to everybody and endangered species and overexploited and salinity problems and so forth. So we're looking at these kind of from this perspective of escasez de agua, but also with the perspective, water scarcity, but also on energy questions, because energy is required for hydropower, and Brazil has an important hydropower sector. Of course, the Colorado River dams, and also the Rio Yaqui, Rio Sonora, not so much the Rio Sonora, Rio Yaqui, Rio Mayo in Sonora have important hydro dams and so forth. So water is in rivers, but water is also in these reservoirs and is being used for a whole series of things. So we're looking at these adaptation processes. How does the science and scientific community, and also the political and the management and policy groups, really try to understand these changes that the regions are facing. This is sort of some of the conceptual thinking that we did of bringing together ideas of risk and vulnerability and what that means for drought and flood, what it means for ecosystems and humans. It's a bit more conceptual if anybody's interested in sort of that conceptual thinking kind of an approach and not just the numerical parts and the quantitative parts in the modeling. I'd be happy to share some of these kinds of conceptual papers that we've done. And I'll pass you a website link at the end. If any of you are interested, you can go and look at some of our publications, and we have them all put out there on that Water Resources and Policy Group website that Ben referred to when he kindly introduced me. So really thinking through what are these adaptive responses, how do we plan with uncertainty? Stakeholders and politicians, especially the naysayers, will say, oh no, bring me certainty and then I'll do some planning. Well, we're never going to have certainty. And in fact, as models get better, we realize just how uncertain they are. Black box, simple input-output models used to be quite certain. They were wrong in many cases, but they were, they were certain. They gave an answer, whereas now we've got this range of answers. We've got this uncertainty to deal with. And that's okay, because it shows that there's an exploration of these kinds of things. And maybe we could come back with some of the questions to understand ecological processes and hydrological processes and social economic processes. What does this uncertainty really mean? Okay, so we go through and do these science policy dialogues. We talk a little bit about that. There's a whole set of practices that our region is actually very well known for. People come from around the world to look at how to do demand management for water. Tucson is a leader in schemes like water reuse. So if we're in these semi-arid regions, water-scarce regions, water-insecure regions, what kind of responses, what kind of adaptation processes do we have? Some are technical in the sense of, we'll have purple pipe water reuse irrigation systems, so we're not using fresh water or aquifer water. But others are more soft path, as we call them. You manage demand, you make the political conscientious, consciousness raising, awareness raising, and those kinds of things. Maybe there's some limits on growth. Is there a regulatory approach that you can say, no more people because, we're already overtapped, we've already overextended. We're very interested in infrastructure, how dams and canals and acequias and groundwater systems, how are they planned? Who plans them? Who uses them? Who owns them? What are the mechanisms for getting water, for harvesting water, for extracting water from these? Because, that's the human hydrologic interface is infrastructure. We pump and we pipe and we put water in dams and, things of that kind. What about this whole ecological restoration? How do we understand ecosystem processes and services that ecosystem services around those? Where would be our priorities for ecological restoration? Very briefly, some work that we've done with the ex-City of Tucson water planner who now has retired and gone into consulting. I like Ralph Mara a great deal. He, really, I think, sees things in some very important ways. And we're doing work in Mendoza, Argentina, a city not unlike Tucson, to really understand these processes of adapting to climate change, uncertainty, water insecurity, allocation of water among these different kinds of sectors. So this is just his title slide. I'm not going to go into the details. But a lot of these kinds of science policy dialogues. This was at IMTA in Cuernavaca and Jutepec a couple of years ago, where although Valentina is wearing a NOAA U.S. sweatshirt here with the logo, she's actually the Servicio Meteorológico Nacional of Mexico, at that time the deputy director, somebody really thinking about water, the water impacts of climate and climate change and so forth. A lot of around-the-table planning. Our maps don't match on the border. These are geologists saying our aquifer deposits of underground water. Wait, we map these geological units differently at the border. It's the same geological unit, not somebody's right, somebody's wrong, but how do we make sense of these sort of cross-border sources of information? And so for some of the Unison, Universidad de Sonora geologists participating, one of the Nogales, Arizona water managers, Floyd Gray from the USGS. So it's not just us at the University of Arizona. These are, agency science people as well getting together. The International Boundary and Water Commission, Jesus Quintanares, with the IBWC, STILA, U.S.-Mexico Commission for Water. And very kind of like last slide here, just a bit of thanks not only to our funders, but we do fund this with money from a whole range of different sources of support. I mentioned that U.S. National Science Foundation project. We also have the Instituto Interamericano, the IAI project. We've had 2 projects from them. They, in turn, are funded with some National Science Foundation, CONACYT Mexico. We have Lloyd's Register Foundation, a private UK foundation that is supporting some of our work. Our partner in Peru, and I realize I didn't talk much about the Peru part of our work, but has USAID partnership now. They're developing their own Center for Water, a proposal at least to do that with CONCITEC, which is the National Science Foundation, CONACYT, but of Peru. And Ben also mentioned to you that CONACYT Mexico and the UVE, with UVE's own resources that come from philanthropic and other sources of support, are also putting money together, not to do this research project that I've described, but to sort of do a broader set of arid region, arid environments, hydrologic, ecologic, social, human, kind of future-looking kind of an approach where, ideas of sustainability, resilience come in at the same time, a very detailed case study science. Let's go in and monitor and measure and do different things at this time. So that's about all I have. If people are interested, go and look at this, http://aquasec.org. WRPG is the Water Resources and Policy Group. If you stop there, you'll get just the Water Resource and Policy Group. We have projects associated with this nexus idea of bringing water, energy, and food systems together. It's a new call for NSF. I hope some of you are looking at that and thinking how to get involved and so forth. So thank you all very much. My slides do go on for a lot longer, but I will actually stop right there. Thank you.
Right. Fantastico, Chris. Excellent. I don't know about all of you, but I sure feel a lot better knowing there's such a kind of extensive and multi-dimensioned approach to such an issue of great importance to us going forward. So, great presentation. And we have some time for preguntas, discusiones. So, please, if you have a question or want to say anything, definitely unmute yourself and feel free to speak up.
Let me ask just who's out there, and if not, introduce yourself. How many participants do we have? And either they could say their field or their discipline, or Ben, you could just say we've got a couple people, and there are ecologists or hydrologists or social science. Who's out there?
There's a lot of people out there.
Yes, I can start. Do you hear me?
Yes.
Okay. My name is Itzel Hernandez, and I was invited last minute, but I'm finishing a PhD, and I study the Colorado River Delta, and I'm looking at a framework of resilience. So I was really glad to see the resilience theme, and it seems quite a multi-dimensional and multidisciplinary approach that you're taking. It looks like a really cool project.
Thank you. Thank you. Tell me a little bit about your questions you're asking in the Colorado Delta with the resilience perspective, if you don't mind, or Ben, would you question with people, or how would you like to do this? I'm interested, or we could do it offline. You can also send me your emails, but I am interested in that.
I want to hear the answer.
Yeah.
I actually approached it. I didn't know how to approach it for a while, and I was very confused at the beginning, trying to incorporate this resilience thing. I was very confused for a long, long time. Then I decided that I could use a landscape approach. So I did a land cover change and trying to study the dynamics of change. And I did basically a landscape change dynamics analysis. So that's one thing. I'm looking at the riparian corridor, and I'm looking at dynamics of change over a period of time. Basically trying to find trying to quantify the dynamics of change through the 1968 to 2010.
Wow. The sources you have some land cover mapping, but you also have some field-based ecological surveys to.
No, because I'm limited with the 60s maps. Of course, there's no way of going back. So I did only imagery, only aerial photos with some satellite imagery later on. Okay. Oh, okay. And then so it's basically just very basic quantification of how much change. How much went from agriculture to forested areas, and how much went back to agriculture, and how much went basically, I try to quantify the balances between agriculture gains, vegetation gains, and how they balance over time. So it's kind of like, at the end, a simple idea in reality, and the probabilities of how that happens over time. Basically.
And one of the things, obviously, that you know in resilience literature is the thresholds are important. So you can sort of have incremental change, and all of a sudden you can hit a particular species mix, or there can be an external driving force that could be a drought or a flood, or a human-caused thing like some toxic spill or something that all of a sudden is going to totally rechange the system, and as that sort of adaptive cycle, which is sort of a conceptual approach, but I think it does get at some of the dynamics that are not sort of linear and gradual, and you can sort of extrapolate them out, because that's where a lot of the uncertainty comes in. And I know that makes our work harder, because now it's difficult to say, well, what we saw
more complex.
68 and 78, we're likely to see something, to 88. No, it could be just completely different, And so congratulations on what sounds like a good project. I'm sure you're well tied in. It's not actually a region of our location that I've worked in much myself, but I'm sure you know people at the UV and Pronatura and Universidad Autónoma de Baja California, right? And good luck. That's fantastic.
And I actually ended having 2 other chapters. One on community dynamics, and actually I'm working with Pronatura using some of their data sets, which are really well collected, and it was hard trying to relate then the community dynamics back to what's going on the land, because I think for the first time, we're going to be able to connect them, but it's not going to appear in my thesis, but I'm going to help with that. But with the monitoring they've done with the full flow that they just happened last year, with that now they finally have a good data set for connecting the dots of bird community, vegetation, and then what's going on with the hydrology in the river. So I'm gonna
approach. You're doing it. So that's what I would think that your group NGen is doing monodisciplinary science. I understand that you are a multidisciplinary group and an interdisciplinary group. So that sounds fantastic.
Thank you.
Where are you based?
I'm actually right now working with Pronatura. So I'm here in Ensenada.
Okay.
Yeah, that's where, and I work with Oswald Hinojosa, who told me about this lab meeting.
Perfecto.
Yeah.
¿Alguien más? ¿O preguntas en español?
Maybe I can just add one more thing. I ended up obviously putting too much in my plate, of course, and basically I was actually very interested in what you're doing at the border, Mexico-U.S. Quantification of ecosystem services. So maybe later on, if I can just contact you. I tried, one of my projects was to do a comparison of dryland deltas within Mexico, the Mexico-U.S. border. So I think I have a good data set for the Colorado, the Yaqui, and the Rio Bravo Grande. And then trying to trace, again, trajectories of how ecosystem services might be changing over the last, at least, it's actually trying to get data for all these places. There's, of course, the problem of how uniform they can be. And I'm actually not getting, I'm only getting like basic data sets for the US side. But I think I got what I can, as far as I can get, of good data sets in Mexico.
Yeah.
The U.S., not so much, but
let me just tell that our Mexican collaborator working on that is Alejandro Castellanos. I don't know if you know him. He's at Unison in Hermosillo. In fact, I'm going to Hermosillo tomorrow. I'll be seeing him, but he's very interested, and at the recent Sociedad Ecológica Mexicana, I don't know exactly, I haven't been myself, but it was in San Luis Potosí in maybe April or something. Do you know that meeting I might be talking about? He's very keen on this kind of riparian ecology, so that wetlands would obviously be part of it, but also more dry riparian corridors, but doing classification. And we sort of him as a ecological physical scientist, we've gotten him very interested in the policy dimension, So he wanted to run a workshop not only on classification, taxonomies, and getting these things properly documented and mapped, but he wanted to say, why doesn't the law in Mexico actually have a riparian category for actually doing conservation practices? So that, one is you have to do the science, but the other is you have to get out and get CONAMP. And I mean, I don't understand that side of it very well myself because I'm more in the water field and I deal with CONAGUA, Comisión Nacional del Agua, but there are the Comisión, right, the Áreas Protegidas and others. Who needs to actually, in Semarnat, who needs to understand that riparian areas have a very specific set of processes and their conservation and their designation and their protection and all that. So Alejandro Castellanos could be a very interesting link for you.
Okay, thank you. I'll look it up. Thank you.
Okay, or if you send me an email, I'll be happy to forward it to him and say, oye, Alejandro, aquí es una pregunta ahí, ¿no?
Okay, thank you.
Bien?
Okay, yes, I'll let the others talk.
Sure.
¿Alguien más? ¿Otras preguntas?
How much does cambio climático come up for work? We have researchers in NGN who are really looking at their own fields or fields, impact of
Climate change? Not in mine, actually. I thought of incorporating a little bit of climate change for ecosystem services as drivers of trajectories of ecosystem services, but I'm not going there because it's just too much for now.
It definitely is covered by other members within the network, from some areas in the Sky Islands to within marine protected areas, or even some levels within, I know, some lizard or mammal species. That's it's fairly dispersed, and that may be one of the themes we can kind of pull out at the summit at the end of October to better identify questions. I have one question, I guess, for either of you. What's the definition of resilience? I mean, it's such a multi-layered theme and term. I'm curious, in this sense, both maybe ecological and then sociologically.
I can give mine.
I'll take a jump. I don't have it right off the tongue, but resilience came out of the ecology literature, right? So Buzz Hollings and others. And then it sort of got into the sort of applied management side. Can you manage for resilience, or which aspects of a resilient cycle can you? And so there's a social-ecological systems resilience definition. Now, of course, resilience is one of those catch-all phrases where psychiatrists talk about resilience. An individual who is resilient to major trauma or stress, psychological, psychiatrically, right? Or a resilient economy, right? And so, yeah, resilience is everything to everybody. But my understanding, the way we work with it, is the ability to overcome or weather shocks and external stresses and provide some level, question, how much is some, okay, but still it's a bit vague, but not come back to the same exact original operating state. That's more of an engineering resilience, which is like, oh, I designed this thing and it hit a shock, it's right back to where it was, it only took that long. In ecological, social ecological systems terms, it reorganizes and provides functionality to the core human and ecological communities of interest. So, and there are various papers, and I in fact teach a seminar on adaptation and resilience in water resource systems, and of course ecosystems and infrastructure come in, but there's a much broader conception of it too, with land use, land cover, and marine ecosystems, and So anybody else want to join in?
Well, let me just, the definition you just gave, Chris, it almost necessitates kind of a baseline of what that functionality is, to then reconnect to.
Yeah, and if I
form status state.
Yeah, and if I can add, actually, going on what you are saying, Ben, is I think one thing that I learned is that you have to recognize the identity and kind of like set that baseline or that set of that description of how is your system and what is your reference line, the baseline that you're gonna assess your system according to a certain disturbance that you're interested. So I think it's that's one of those classical papers is defining resilience of what to what. I think that's one of the core questions always. What, because it could go in many directions and it could be it's moving. It's a moving target, and you have to bound it. And bounding it, I think, is the first thing. Bounding your system and defining resilience of what to what is going to help you a lot to kind of piece out.
That's helpful. Yes, I think that's very helpful.
Yeah.
Oh.
And I was wondering can we look at I'm interested in the first set of your slides, if we can access them later on, or would they be available?
Sure, I'll be happy to put them on, maybe I'll make sure Ben gets them and you can distribute them. I think right now they're too large to just send everybody, but I'm sure I can do some Dropbox or reduce them in a PDF to, a smaller
a PDF or something, yeah.
We can figure out the best mode, and then for sure we'll have the archive of this meeting on our website, and we'll have a link or the PDF file there.
Okay.
Yeah.
Thank you.
Yeah, great. Well, maybe we should leave it there. Lots of good discussion potential, but and then Nita, you can. I don't know if you're a member or the other people that are signed on, but please make sure that if you want to connect and with the network, to go on to the website and to create a profile, and then that's a way we can all better link in and know who's doing what and where.
Yes, I'm already a member.
Okay, if that's so.
I'd like to do that too.
Good. All right. Well, next time, in about a month's time, September 16th, we're going to be joined by Heather Leslie and Javier Basurto, talking about, again, their community-based work on marine protected areas and using the southern portion of Baja California as a model for sustainable marine protected areas. So their work is fantastic. It's going to be a great joint lab meeting, and with more information to come on other exciting things. Christopher, thank you so much for joining us this week, and thank you all for participating. All right.
Pleasure.
Thank you. That was a good presentation. Thanks a lot.
Thank you. Goodbye.
Bye, everybody.
Bye. Bye. Goodbye. Where do I turn off my